Okay, so we want to talk about the sum or difference of cubes, and the good news here is we have one process to remember for both of these. The bad news is it is something that you do have to memorize. The best I'm going to be able to do to prove it to you is to multiply it back. So these are the two things that we are going to be working with. The process that I'm going to talk to you about is going to work with both of these, but these are the two things. And you'll notice that they are perfect cubes, and there is a subtraction here, and here we have, again, perfect cubes, but with an addition. So these are the two ideas. The first thing that we need to do is recognize perfect cubes. Now, these are things that we probably don't remember quite as well, but, you know, things like 2 cubed is equal to 8, 3 cubed is equal to 27. I'm not going to go through all of these. 4 cubed is equal to 64. 5 cubed is equal to 125. And you get the idea. And you do want to have them, my advice is to have them memorized through 10, mainly because what makes this a little bit easier is just recognizing, you know, it's perfect cubes. So when we get to binomials, you know, we've really got 3 things we can do. We can look for a GCF, which we always do anyway. And then we have to determine whether it's perfect squares or perfect cubes. If it's neither perfect squares nor perfect cubes, then it's done. So again, this is one of those things that can be really handy, just recognizing what's in front of us. That said, we also want to go about recognizing perfect cubes with variables. And we see that a cubed is a perfect cube, and we know that that means a times a times a. And this works pretty much, you know, in a similar way to to how we did the squares. Let's say we have a to the 9th and a to the 8th. So again, the idea is we have to have something that's exactly the same that we're multiplying 3 times. So a cubed times a cubed times a cubed. And remember what's happening here, because we're multiplying like bases, we keep the base and we add these exponents. So 3 plus 3 plus 3 is 9. So this is a perfect cube. Now how about this guy? So this was a cube, so now let's go ahead and do a. And what the exponent would be. Well, you know, we know that it has to be exactly the same. So, all right, well, if it's 2, well, when we add that together, we get a, but 2 plus 2 plus 2 is 6. So that doesn't work. If we tried anything else, it wouldn't be the same. So the exponent wouldn't be the same. So if we had, you know, a to the 3rd times a to the 3rd times a to the 3rd, well, we know what that gets us. So that's a to the 9th. So we put a 2 in there. So now we've got 3 plus 3 plus 2 is 8, but they're not the same. So this is not a perfect cube. The good news is it's just as easy to recognize perfect cubes, and all you have to do to recognize a perfect cube so the variable is a perfect cube when the exponent is divisible by 3. So that's how we recognize our variables are perfect cubes. So this may take a little bit more work, particularly for the numbers, because it's not something that we're as familiar with or we remember as well. Now, this is the list of steps that we need to be able to do to factor the sum or difference of cubes. And I know it's long, but it's literally taking every teeny tiny little piece. My suggestion is for you to either print this page or I do have this in the notes, so you can certainly go to the notes and pull it off of there. But you're going to want to follow these steps as we're doing this. And you'll notice that when I start doing examples for you, I am going to talk through most of these steps, but you're going to see that it goes much more quickly than this 12 steps makes you think it's going to go. So just, don't let the fact that it's that many things intimidate you. The fact of the matter is that you are going to have to do some memorizing here. So for those of you who like to memorize stuff, this is totally your game. So I'm going to start with this. I wanted to get a little bit more room because I want to do an addition one also. So here we've got a perfect cube. We can see it's a perfect cube because the x cubed, and the 8, we already talked about that, so that one is a perfect cube. So we're looking at x cubed minus 8. Now I'm going to talk through this. I'm going to try to make it as slow as possible without it becoming too horribly tedious. So let's go ahead, and the first bit is we recognize it's perfect cubes. Now I'm going to write my little parentheses here, and I'm going to take the cube root of the first term. So the cube root of x cubed is x. I bring this first sign down, minus, and the cube root of the second term is 2. So that is the first bit. Now I'm just going to put a line through this because we don't want to look at it again. Because everything that we're going to do now is going to be based off of our new polynomial that we just created. So the next step, we do our next parentheses, and you'll notice that it's longer. And it's longer because we're creating a trinomial here, so it does take a little bit more space. So we square the first term, so that's x squared. The sign is negative, we change it, so we change the sign. We multiply the two terms in the first binomial. The next sign is always a plus, and then we square the second term, and we're done. So that long list looks way worse than it is. The next thing that I want to do here is I just want to prove this to you. So we're going to multiply it back. So we've got this x minus 2 x squared plus 2x plus 4. And we're going to multiply this back. I'm going to do a little double distribute. So I've got the first term in my binomial times the trinomial. The second term in my binomial times the trinomial. Now I'm just going to multiply, and I'm going to do this again fairly quickly, but x cubed plus 2x squared plus 4x. Now we've got the minus 2x squared minus 4x and minus 8. Now as we go back to look at this, the next step whenever we multiply is to combine like terms. So we see we've got an x cubed. There are no other x cubes, so we bring it down. Now we've got a 2x squared and a negative 2x squared. Well, the positive and the negative make that 0, so that term is gone. Now we've got a positive 4x and a negative 4x. So again, the positive and the negative, we add them together. That's gone, and we're left with the negative 8, and we are back to our perfect cube. I want to do one more to introduce you to this, and I'm just going to do x cubed, but I want to do a plus. So we'll do x cubed plus 27. And I just want you to see how it works with the addition. Is the process, if you remember, what we did was exactly the same. Or is exactly the same, rather, excuse me. So now we look at our binomial, and we see it's perfect cubes, it's the sum. So square root of the first, square cube of the first, and then again the cube root of that one. Keep the sign. We're not going to look at that again. Now we square the first term Here it's a plus, so it changes to a minus, so we change the sign. Then we multiply these two terms. So that's a 3x. The next sign is always a plus, and then we square the last term. And we're done. So you see it works for both the plus and the minus. You don't have to memorize where signs go or anything else. You just remember that you keep the sign in the binomial and then you change that first sign in the second. The third sign is always a plus. And if you remember it in the order that I gave it to you, it really is ideal.